In this tutorial, we will add more tools to our vanilla JavaScript coding toolkit, and I will show you how to create variations of particle rain effect. Using vanilla JavaScript and HTML canvas for creative coding solves two problems at once. We can build awesome animations that will work in any browser and on any website, and at the same time we are learning about important JavaScript techniques that can help us to pass coding interview and get hired as a junior front-end web developer. We built this effect from scratch, line by line in the previous episode, and I explained how everything works. The end result was black and white pixel rain. Today we will add colors, explore different movement patterns, apply filters, shapes, blend modes, turn it into a fire effect, and couple more things. Welcome to the laboratory. It's time for another creative coding experiment. Hope you have fun. Click like, please. In the previous episode, we built this black and white pixel rain effect step by step completely from scratch, and I explained how everything works. Let's just have a play with it and create variations using different JavaScript tools and techniques. Let's see what comes out of that. In Style CSS, I moved the canvas slightly more upwards. First of all, I will quickly swap to a different image. We are using data string that contains all image data. To replace it, I just enable word wrap in my code editor. I select beginning of the string, then I scroll all the way to the end, and on my Windows PC using VS Code editor, when I hold down Shift key and click here, left click, it will highlight all the code in between. I delete it and replace it with a different image. When replacing images in your projects, make sure canvas width and canvas height on lines 7 and 8, as well as in Style CSS file is updated to match dimensions of the new image you are using. In my case, I made sure the new image is the same size as the old one. I gave you a challenge last time, instead of black and white effect, to try and dynamically assign colors of the original image to the particles as they flow over areas with different colors. Solution is very simple. We already calculated red, green and blue here anyway to get our brightness, so I just create another property in custom cell array called cell color. And I concatenate string RGB plus red plus comma plus green plus comma plus blue plus closing bracket. Now this little cell array we create for each pixel contains two values, relative brightness and original color. To use this color, all I need to do is go down here to draw method on particle class, and on line 67, instead of setting fill style to white, I set it to this new color property inside cell array. Same as we do with brightness on line 56. I go down 2 levels inside my custom mapped image array, and inside cell array I see that cell brightness is the first property, so index 0, and cell color is index 1. Down here on line 67 I set the last index to 1. And here we go, we are drawing in color. That was easy. Let's play with particle movement now. We will face a weird bug here. I will tell you why it's happening, and I will show you easy way to fix it. When I increase vertical Y value, particles fall down. What if at the same time I increase horizontal X position? Oh, here is the bug. One of our particles moved outside the canvas area, and because of lines 56 and 68, JavaScript doesn't have indexes for these coordinates in mapped image array, and everything breaks. In this case, I can fix it by resetting X and Y correctly. On line 61, if vertical Y position reaches bottom of canvas, I set it back to 0, and I randomize X horizontally. I will also check when horizontal X position is more than canvas width, and I set X back to 0, and randomize Y vertically. This solved the bug we are getting when particles move outside the canvas area, but for the next effect I want to use trigonometry and make particles move in waves. I won't be able to make sure particles never reach outside of canvas area when we have complex flowing movement like that, so I will have to fix that bug in a different way. By the way, you can also change angle at which particles fall by adjusting lines 59 and 60, like this. First, let's try to apply some fluctuation to particles movement and let's see what happens. On line 52, inside particle class constructor, I create this.angle property. This will be individual for each particle, and the reason I make separate angle for each particle is because I want each particle to fluctuate at different speed depending on the brightness of the underlying area, just like we did with movement speed earlier. Let me show you how. At first, I will increase this.angle inside update method for each particle by 1 for every frame. So far, all particles will have identical motion. I take that angle value and I pass it to trigonometry function called math.sin. This will just take the angle value and periodically run it between +1 and -1 over and over, which will give us fluctuating movement. Immediately when I do it, I will get an error. It is because particles wiggle now, and on line 61 I say this.y is movement plus this wiggle created by math.sin. The problem is this. Imagine this particle is all the way to the bottom edge and math.sin is added to that position on line 61, making the particle move further down outside the canvas area. In reset check on line 63, particles this.y is not past the bottom edge of canvas yet, so it will not reset y to 0. But because we added math.sin to it on line 61, particle's actual coordinate is outside canvas. Normally that wouldn't be a problem, but here on line 57 I calculate speed of particles based on their coordinates, because each set of coordinates has different underlying brightness and the speed depends on that. My mapped image array on line 57 has only values for actual image dimensions, so when I ask it to access vertical index 710 when my original image was only 700 pixels tall, this index in mapped image array doesn't exist. In this case, JavaScript will not know what to do and the entire animation will stop. In console log you will see something like this: cannot read property, some number of undefined, because we are asking for index in mapped image array outside the canvas area, and mapped image array is set exactly to match canvas dimensions as we explained in the last episode, so this index in that array doesn't exist. So on line 57 we only want to assign a new speed value if particle is within canvas, so that we can check for brightness of underlying area by accessing associated indexes and mapped image array. I will just simply do an if statement here. If vertical y position is within canvas area, this.position1, and at the same time horizontal x position is not undefined as well, only then assign a new value to this.speed. Otherwise just use old this.speed value that was assigned in previous frames. That's fixed, but I get another error. On line 76, the same issue here. We are asking for color of the original image, but particle is currently outside canvas area, so mapped image array doesn't have color data for this position. I do exactly the same fix. If statement, only if horizontal and vertical position have corresponding indexes in mapped image array and are not undefined, only then change fill style to a new color. Otherwise, fill style will just stay the same color from the previous frame. Problem solved. Now we can give particles any crazy movement and the effect will not break. The wiggle is barely noticeable. Let's make particles spin around properly. I also add circular movement to this.x. I change sine to cosine. On line 61, angle is increased by 1 per frame of animation, way too fast. Look what happens when I slow it down. We can actually see the circular movement now, but all particles are moving in the same rhythm. I put angle property on particle class constructor on line 52, which means each particle has its own individual angle value. If I wanted all particles to move the same like this, angle could have been a global variable and it would have saved JavaScript a lot of calculation. Since we have separate angle for each particle, let's make each particle spin around based on its this.speed property, which is individually calculated on line 58 based on brightness of the underlying area, meaning that the dark areas of our image will create different circular patterns than light areas. This.speed is too fast. Let's divide it by 10. Interesting. Making it even smaller number will really show off what's going on. Because particles move slower over light areas, just because they spend more time in there, they are more likely to make a complete spin, and it kind of looks in some places like particles are actually bouncing off the light areas in the image. How about we create our own spectrum? That's also very easy. Up on line 9, I create a constant variable called gradient1 and I set it equal to ctx create linear gradient. This is a built-in canvas method. It expects 4 arguments, 2 sets of coordinates. These determine direction of the gradient. Imagine drawing a line between them to see the direction. I want my gradient to go from top left corner, coordinate 0, 0, to bottom right corner, coordinates canvas width, canvas height. I take this gradient1 variable I just created and I call addColorStop built-in method on it. It expects 2 arguments, position between 0 and 1, and color we want at that position. I will just speed this up and make some color stops to create rainbow. My color stops will be at 20%, 30, 40, 50, 60, 70 and 80%, and the colors will be, for example, pink, red, orange, yellow, green, turquoise and violet. To apply this, I can simply go down to line 84. I disable colors from the original image for now, and I set fill style to gradient1 variable we just created. Up on line 9, you can change these coordinates to change angle of your gradient. What if I want size of particles to be small in dark areas and larger in bright areas? Very simple to do as well. I go down to line 70 inside update method and I set this.size to this.speed, as speed already depends on brightness anyway. How about speed times 2? Maybe speed times 1.5? Let's comment out line 88 and uncomment this to get original colors. How about instead of filled circles we use stroked rectangles? This works, but we didn't set our stroke style, so it defaults to black. I just added here on line 87. The rectangles are too small, maybe size times 5. How about size times 3? Interesting. You can put any drawing code here to represent each particle, even more complex shapes or image from a sprite sheet like we do in game dev videos, for example. If you use more complex particle shapes, you have to consider the number of particles that make up our effect. It might be a lot for our computer to handle and draw all these complex shapes. Let's try to replace particles with letters. For example, with capital M. That seems to run okay, even though replacing circle with a letter is a bit more demanding on performance. How about I create a constant variable called letters and I set it equal to an array. The array will contain some letters. For example, we can spell Mandalorian. Or let's just do M-A-N. Then, down here in particle class constructor, I create a new property, and each particle, when it is created, will be assigned one of these letters randomly. I do that by saying this.letter equals letters array I just created, and index will be a random number between 0 and letters length. This will give us numbers with decimal points, but array has only indexes 0, 1 and 2 because I have 3 elements in my letters array. To make sure we only get integers, whole numbers without decimal points, I wrap it in math.floor, which will round it down to the nearest integer. Now I can take this new letter property I just created and in draw method on line 95 inside fill text, instead of hard-coded letter M, I pass it this.letter. Now our particles are random letter from that array. Up on line 25 I reduce the number of particles so that we can actually make up individual letters better. Inside animation loop I comment out line 12 that changes particles opacity based on their movement speed. And I set everything to full opacity. Global alpha equals to 1. This looks pretty cool. What if I want only a certain percentage of my particles to be letters and the rest regular circles? How do I control that? I can, for example, create this.random property on particle class constructor and I just set it to math.random like this. Math random, code like this, returns a random small number between 0 and 1. Each particle gets assigned a different random number at the point when the constructor gets called and that particle is created. On line 96, inside our custom draw method on particle class, I can say if this.random is less than 0.1, which should roughly be in 10% of the cases, then draw particle as text, as one of the letters from letters array. Else, draw it as a circle. This way, you can control different percentages of particles and give them different properties based on that. You can do anything here. If I change 0.1 to 0.5, now approximately 50% of my particles should appear as letters. I can use CTX font to set text size and font family. Let's try 20 pixels Arial. I can tweak the amount of text particles by tweaking if statement on line 97. I can replace text with stroked rectangles, make them larger. Okay, back to the circles. This effect also works with the global composite operation property, where you can blend particles together in different ways. I like when particles flow from one side and wash over the image. Until now, it only ever happened on the first page load, if I set start in X or Y position to edge of canvas. What if I want particles to come in waves and periodically create this splash movement? Let's create a variable that will switch between two values. I will call it, for example, switch. Oh no, that's a reserved word in JavaScript. Let's do switcher, and another one called counter. Both will be let variables because I will be changing their values. I create setInterval that takes two arguments, callback function to run and how often in milliseconds to run it. I want it to run every 500 milliseconds. Every time it runs, I increase counter +1, and now I can use that to set periodic events in my codebase. I say if counter modulus 12 is equal to 0, modulus operator, percentage symbol, is also called remainder operator. This if statement means if counter value is divisible by 12 with a remainder of 0, which means as counter increases by 1 every 500 milliseconds, this if statement will be true at 0, 12, 24, 36 and so on. Every time counter variable from line 20 increases by 12, set switcher variable from line 19 to its opposite value. Switcher times equals -1. At first, switcher is set to 1, so 1 times -1 is -1. Then it runs again, switcher is -1, so -1 times -1 is +1. It will just repeat and switch between +1 and -1 over and over every 12 cycles of this interval. On line 84, inside custom update method on particle class, I can say if switcher is +1, do something, else do something else. Let me show you what global composite operation does. I can set it, for example, to soft light. Oh, I actually misspelled it. It's supposed to be operation. You can see these values control composite in or blend in mode operations on canvas. They can blend shapes, adjust contrast, hue, brightness, and other properties of canvas, giving us different effects. There are over 20 different values. Soft light affects how light and dark is displayed. Luminosity preserves luma, or brightness, of the top layer, and it also preserves hue and chroma of the bottom layer. From their official descriptions, it's really hard to guess what will the final result look like, so I just try and see what happens. Some of them, like source out, might freeze your browser because what it does is performance intensive when you have so many particles like we do in this effect. So be careful. I can use my custom switcher variable to switch between two different blend modes periodically, just for fun. Combining two specific ones might create something interesting. Let's swap between luminosity and lighter. At the same time, I say if counter modulus 10 is 0, every 10 cycles of counter variable, set X and Y to 0, so particles splash over the canvas over and over. What if I randomize it this way? Let's reset Y to 0 and leave X as a random number. Now the image automatically switches between two different blend modes, and particles periodically reset so they can flow over the image in a wave again. Let's comment out this bit. I can swap sine and cosine on lines 94 and 96. This will affect the circular path particles take. Tweaking anything on these lines will affect particle movement in a major way. I can, for example, make particles move upwards. If I do that, I need to adjust reset check on line 96. I'm just playing with the reset checks, trying to get it right. On line 67, I can change particle size. Actually no, because I'm overriding it on line 82 because I wanted particle size to be relative to particle's current speed. I'm trying to build a fire effect now. I need to get the right size here. In Style CSS, I apply CSS filters. I will use blur 2 pixels, and then I sharpen it with contrast. Contrast is just a number without pixels. Adjusting size on line 85 will affect how the fire looks like. What variations can you come up with? Do you have any ideas how to tweak this effect and create something interesting? Let me know. Click the like if you want more creative coding tutorials. Everything on my channel is vanilla JavaScript with no frameworks and no libraries. I have canvas animations, CSS effects, and JavaScript game development playlist. You can check them out if you want. I will see you there.